Welcome back to the second video on probability. So in the previous video, we looked at what exact probability is, and we looked at how it is applied in the real world, and we said it has so many amazing and fascinating applications. But as always, before we get to do these applications, firstly to understand the basics that are covered in high school before you can do all this advanced stuff, which you will do in varsity, you'll do in the workplace. Like I said, probability allows us to become the prophet. So think of yourself as a prophet. If you are doing probability, you are a prophet. You can tell the future. But back to the high school probability. In high school, you'll need to know these couple of basics of probability, which are taught in your curriculum, which involve probability rules, which are covered from grade 10, which are these ones, all of these. And then also need to know how to work with Venn diagrams, and then how to work with tree diagrams, and then how to work with contingency tables. And then lastly, if you are doing grade 12, also need to know how to apply the fundamental counting. So it's a fundamental counting principles. But all of these, they are covered in grade 10 and 11. Then grade 12 just get this new topic or subtopic under probability. And this is 15 marks for your grade 12 paper 1, and for your grade 10 and 11 it is 20 marks, and this normally becomes the last question for paper 1. It's a very easy topic to grasp. So we'll first look at getting the probability. Like for example, if in your classroom we've got maybe you've got like maybe there are 50 learners in a classroom, and out of these 50, 30 of them it's girls, 20 of them it's boys. Then now a question says, I go into your class, I choose any learner at random. By random, I mean that it's more like I close my eyes, then I just pick any learner in a class without having to having some knowledge, or like saying I'm gonna pick this learner specifically, but I pick without knowing who am I picking. So then question will be, what's the probability of choosing a boy? That's gonna be what? It's gonna be, first, how many boys do I have? I've got 20 boys. That's gonna be 20 over how many learners in total? Over 50, which ends up being 20 divided by 50, it ends up being 0.4. So which is 40%. So there's a 40% probability that I will pick a boy if there are 20 boys in a class of a total of 50 learners. What about the girl? Probability of picking a girl would be, how many girls are in this class? There are 30 over 50, which is all the learners in a classroom. And then this will end up being 0.6 to 60%. And that is the basic of probability. It's just looking at how many people do I have in total, or how many outcomes do I have in total over what I want, or how many outcomes do I have in total. It's going to be the denominator. Numerator is going to be what I want or what I desire, depending on whether I want to pick a boy or a girl. And then we look at difference between relative frequency and theoretical probability. So relative frequency, or it's also called empirical probability or experimental probability. This is the case where probability is estimated or calculated after performing a large number of trials, an experiment, or conducting a survey involving a large number of people or items. So, as the name says, it is relative or experimental. You conduct an experiment, and then after the experiment, you use the experiment or the past data to calculate the probability or the relative frequency. And this is estimated from the data. If you conduct a survey, you use your survey results or the data to estimate the probability, which we call relative frequency, because it's based on the experiment or the survey. And this is how we find the relative frequency. We will say number of times an event occurs divided by number of trials that were performed. And then if we look at the theoretical probability, this one is based on the chances of something happening. So we don't conduct an experiment here. So how we find it, we look at the number of ways or number of favorable outcomes over the total size of a sample space. That's how we get the theoretical probability. But these two, they are the are both between 0 and 1. They are both probabilities, just that relative frequency. It's based after conducting an experiment, but theoretical probability is based on the chances of something occurring. If you can look at an example, you're not gonna look at tossing a coin. So tossing a coin 50 times, and then we got, and then you say it landed on heads 22 times, and then on tails how many? 38. Sorry, 28 times. 28 times. So you conducted an experiment where you're tossing a coin, you're flipping the coin 50 times, and out of those 50, 22 times it landed on heads, and then 28 times it landed on tails. Now we'll just find, then now they say, the question will say, find the relative frequency that the next toss will land to a head. And then number 2, we will find the theoretical probability. So we'll find the theory. So this is what you normally use when you play games. When you toss a coin. So you're gonna find relative frequency. So here we had an experiment. We flipped the coin 50 times, and then we got 22 times it was heads, 28 times it was on tails. Now the question says find the relative frequency. That's the next coin. The next coin toss will land on a head. So we know that relative frequency looks at an experiment. So there was an experiment here, we're gonna use this. So relative frequency for heads, it will be, we said relative frequency, number of times event occurred. Our event in this case, it is a coin landing on a head. So how many times did that happen in our experiment? It was 22 times landed on heads. So it's going to be 22, but then the denominator is going to be number of trials that we conducted. In this case, we conducted 50 trials because we flipped the coin or tossed the coin 50 times. And then we'll get that this becomes 22 divided by 50, which gives us 0.44. So now this thing is in the next toss, which is the 51 toss, there is a 44% chance that our coin will land on heads. This is based on an experiment that you conducted. But now if I say to you, find the theoretical probability that the next coin toss will land on a head. Remember this one, we say it doesn't look at an experiment. We conduct no experiment on this one, so we ignore any past information here. So what it says, this one, it will say theoretical probability is going to be total sample size of a number of favorable outcomes over total size of the sample. So in this case, we know that we are flipping a coin or tossing a coin. A coin could either land on heads or tails. So we've got only two options. So we've got two in the sample size, and then we want to get heads. Only got one head in our coin. It's either it's head or tail. So it's gonna be one because we only have one head here. So the probability is gonna be 0.5. You see here, we didn't look at how many times we flipped the coin before, or how many times we tossed the coin before. Just looked at like how many sides do we have on the coin, it's head or tail, and then expect the probability to be half. So it's the difference between these two relative frequency. Looks at the trial experiment, but this one it just looks at the chances of that event occurring without any conducting any experiment. That's the bottom line between these two concepts.